Today's lesson is about evaluating inverse trig functions. First of all, let's go over how inverse trig functions are defined. As we know, only one-to-one function has an inverse function. So for cosine function, the domain is restricted as 0 to pi. And a range that is -1 to 1. So for inverse cosine function, domain will be -1 to 1, and a range will be from 0 to pi. So for sine function, the domain is restricted to -pi/2 to pi/2. Range, that's -1 to 1. Because only the domain is restricted like this, then sine function will be one-to-one function. Therefore, we have an inverse sine function. For inverse sine function, we switch the domain and the range. Domain will be between -1 to 1, and a range will be between -pi/2 to pi/2. So for tangent function, the domain is restricted as -pi/2 to pi/2. Since -pi/2 and pi/2 is not in the domain of a tangent function, therefore we use open parentheses, that's -pi/2 to pi/2. Range, no ending points at the bottom, no ending points at the top, so we see all real numbers. Therefore, for inverse tangent function, domain is all real numbers, and a range will be from -pi/2 to pi/2, open parentheses. Now let's show inverse trig functions in the coordinate plane. We label 0 pi/2 and a pi. This is different from trig function. This will be -pi/2. So when domain for inverse sine, cosine, and a tangent is positive, which means your answer will be reference angle. If it's a special angle, it will be this pattern, pi/n pattern. When domain for inverse cosine is a -x, the angle you use pi minus a reference angle. If it's a special angle, then we got to use this way to show that n-1 pi/n. And also when reference angle equals 0, then pi will be on the second quadrant, that's pi. For inverse sine and inverse tangent, the domain is negative. Then the angle will be the fourth quadrant. Pattern will be angle equals negative reference angle. If it's a special angle, we use -pi/n to show that. This diagram shows all 6 inverse trig functions in the coordinate plane. Pay attention to inverse cotangent of a -x. That's range will be between 0 to pi. It's different from inverse tangent of x. The range for inverse tangent of x is between negative pi over 2 to pi over 2. Here are steps for evaluating the inverse trig function. Make sure inverse trig function exists. That means check the domain. For example, for inverse sine and a cosine, that's between negative 1 to 1. Then we do the backward of QRS. In other words, we do sine first, then reference angle, then quadrant. Before we work on evaluating of inverse trig function, draw this chart. First of all, first quadrant, second, and a fourth quadrant. For inverse cosine of negative x, then the pattern will be n minus 1 pi over n. When reference angle is 0, that's pi. So label here is 0 pi over 2. This is pi, negative pi over 2. For fourth quadrant, if we have a inverse sine of negative x or inverse tangent of negative x, then pattern will be negative pi over n. For first quadrant, the pattern will be pi over n. If it's not special angles, we can use reference angle to show that. The first quadrant, that will be reference angle. For the fourth quadrant, you will get the negative reference angle. For second quadrant, you will get theta equals pi minus reference angle. Then we're working on QRS backwards. For number 1, we do the QRS. Check the sign of this number. This is a positive, means a first quadrant. First quadrant, that means the reference angle will be the solution. So we know that sine pi over 2 equals 1. Therefore, reference angle is pi over 2, means the answer is pi over 2. So if domain of inverse trig function is positive, reference angle will be the answer. Let's go to number 3. The reference angle, you will get the pi over 4, because sine pi over 4 equals square root of 2 over 2. Let's go to number 2. We do QRS backwards. We have negative. This domain is negative. And I'm working on inverse sine. Let's go to fourth quadrant. Look at this. Go to fourth quadrant. So I write down fourth quadrant. The pattern for the solution will be negative pi over n. Look at this. Negative pi over n. So what's the reference angle? Since sine pi over 3 equals the square root of 3 over 2, that's a pi over 3. So the answer will be negative pi over 3. Negative pi over 3 will be the solution. Let's go to number 4. QRS backwards. We have this number is a negative domain. Then we working on inverse sine means fourth quadrant. Pattern will be negative pi over n. For reference angle, since sine pi over 6 equals 1 over 2, therefore pi over 6 will be the reference angle. Then the answer will be negative pi over 6. So I write down negative pi over 6. That's the answer to question 4. Now let's go to number 10. For number 10 and number 6, this is just a positive domain. That's why we go to the reference angle. Reference angle for number 10, that's pi over 3, because cosine pi over 3 equals 1 over 2. This one, that's pi over 2. Now let's go to number 7. For number 7, we're working on QRS backwards. We have negative sign for the domain of inverse cosine. According to this chart, we know that go to the second quadrant. So second quadrant, the pattern will be n minus 1 pi over n. For reference angle, we got pi over 4 because cosine pi over 4 equals square root of 2 over 2. That's how you get the pi over 4. For second quadrant, n equals 4 this time, we got the 3 pi over 4. So that's we got 3 pi over 4. That's the solution for number 7. Be careful for 3 pi over 4. Some students got negative 3 pi over 4. It's not correct, because make sure you have to follow this pattern. That's n minus 1 pi over n. It's no negative sign before that. Now let's go to number 8. We have QRS. Reference angle will be 0. This is sine, that's a negative. For inverse cosine, let's go to second quadrant. For second quadrant, when reference angle is 0, that means pi will be the solution. So equals to pi. Because when reference angle is 0, you cannot use this pattern. For second quadrant, the reference angle for pi, that's 0. Now let's do some practice for inverse tangent. For number 14, that's reference angle will be 0. For number 13, reference angle will be pi over 6. Since domain is positive, that's you get the reference angle will be the solution. For number 11, we do QRS backwards. We figure out the reference angle first, that's pi over 4. Since sine, this is a negative, we're working on inverse tangent. That means go to the fourth quadrant. Negative pi over nth pattern. So I go to fourth quadrant. Negative pi over n. That's the pattern for the solution. So we got negative pi over 4. We got negative pi over 4. For number 12, since domain is negative, we go to QRS. Do the backwards. Reference angle first, we got pi over 3 because tangent of pi over 3 equals the square root of 3. So we got the reference angle. For domain, that's a negative. Inverse tangent, we go to fourth quadrant. Pattern will be negative pi over n. Therefore, your answer will be negative pi over 3.